So I had a question to review and compare the neural adaptations based with the muscular, or in this slide we're going to see structural changes. So to do that, we're going to highlight what's kind of known as a classic study in exercise physiology, in a graph you see in most textbooks that kind of outline this. So basically, to kind of set ourselves up for the graph first we're going to look at time on the x-axis. So and here we're talking about time spent exercise training. Specifically here, when we're talking about exercise training, as the slide highlights, we are focusing on resistance training, not aerobic or endurance type training. On the left-hand side is progress, and by progress what we're really meaning is the improvement in strength. Of course, for most people, that is the goal of resistance training, to improve strength. So let's first highlight then this top curve, which is in blue, which is the improvement in strength. The first thing that I will note is that this is for a naive individual, so someone who has never strength trained or it's been a long time. This curve is different, and we'll highlight how it's different for people who have been lifting weights for a long period of time. So a person comes in, they start a training program, what happens? Hopefully you're relatively familiar with this concept here. So if we look in the blue, that an individual will make relatively strong, rapid gains in strength relatively quickly. So the graph here in line is showing that when a person begins training, improvement is seen very rapidly and very consistently. Over time, again, those improvements in strength get harder and harder to accomplish, and a well-trained individual has a very difficult time improving in strength, and oftentimes we call that a plateau in muscle strength. So that kind of gives us our baseline. So person who's never lifted, they start lifting in that program, they progress really, really quickly, and their strength goes up very, very quickly over a relatively long time period. So here again, we're looking at maybe 6 months. We start to kind of see a plateau or a very small, slow improvements in strength. Obviously, if the person has been lifting for a long time, right, they're on this part of the curve. So, you know, this one shows flattening, but it is possible. So as people continue to lift over a long period of time, we will maybe start to see some small improvements. But to get gains in strength, it takes a lot more time and effort as opposed to someone who's new. So the next thing that we want to look at is what are the two components that make up these improvements to strength. There are two primary factors, and that is neural changes and hypertrophy. So what do we mean by neural changes? So we're going to stay relatively broad in this video, but just talking about the concept of our brain and or the motor programs responsible for producing these lifts improve over time. So the idea is that you have improved your learning or your ability to lift. For example, in some studies that have kind of shown this is take someone at the beginning of a study and you bring them in and you do a 1 rep max, and you bring them in a week later and they haven't lifted any weights. Their 1 rep max would actually increase because there was a little bit of learning that went on despite no lifting. So they got slightly better at lifting. The other classic paradigm that we learned in exercise physiology is the cross-education to kind of demonstrate this. And this is where the classic example is doing like a leg press with only one leg. So I'll use my hands as legs just for the video here. But so they lift one leg, and then they come back after several weeks of training, and what they learn is obviously the leg that did the lifting, it gets stronger, but the leg that did nothing gets stronger as well. The reason, there's no changes going on in the muscle that didn't lift, so it's not doing anything. There's no improvements in size or anything like that. But what it's telling us is that we learned to be able to do that lift with our right leg. We were able to do small changes to the motor program that made it more efficient, and we were able to do the lift, and therefore we see improvements in strength. Again, a classic example of this, if you take handwriting to take it out of exercise physiology and you are to write your name, let's say I'm right-handed, so I can write my name relatively well. I can write it with my left hand, it's going to be pretty sloppy and terrible, but the idea is that I learned how to do it, and so that learning goes over to the left side here. So that's kind of how that works. In other words, to kind of sum up that general idea is that there are improvements in our neurons or brain function that can improve strength. And so this is one of the things that really happens at the beginning of training. So compared to structural changes in the muscle, specifically we're talking about hypertrophy or the muscle getting larger, neural adaptations occur in the beginning of weight training. So here, the orange section, you see that the improvements in strength early on are primarily due to neural adaptations, so learning to do these exercises slightly better. It's the primary reason we get so much stronger really quickly, because we're able to learn relatively fast. And indeed, this kind of makes sense if we shift to our second half, which is, sorry, our third part of the figure, which is the hypertrophy part of this, is hypertrophy takes a relatively long time to happen. And indeed, this makes sense, right? You can go into the gym and lift for a couple weeks. You'll get stronger, but your muscles won't be noticeably larger. Right, and so to do that, to actually see improvements in size, that takes a relatively long time lifting. So basically, when we put these two together, right, our rapid improvements in strength early on, in this graph it shows typically less than about 8 weeks, the improvements in strength are due to neural or learning adaptations, whereas improvements in strengths after this learning has occurred, you notice that the neural adaptations plateau and basically don't get any better. You can't learn to do a lift all over again and get any better, right? And so improvements in strength over the long period of time are due to structural changes, namely hypertrophy or improvements in size of the muscle, in order to improve strength long term. So once neural adaptations occur, it becomes much more difficult to improve, and we need hypertrophy in order to do this. So hopefully that clears up this topic and kind of summarizes it in a broad enough yet provides enough information to kind of understand the difference between neural adaptations, changes in the muscle or hypertrophy, and the relative improvements in strength.